Welcome to Wickerson Studios. My name is Michael Wickerson. I have been busy this summer, 2021, and I wanted to do a very kind of back to the basics a little bit, but it'll go a little mathematical, computer-oriented, programming pretty quickly. I'm going to start with this, and it's Math Computers and Grasshopper Goes a Long Way, Wickerson Studios, summer 2021. It's inspired by the Euclidia cell phone app, which is highly addictive. If you haven't done it, I would advise going into it. But I thought with Grasshopper, I could take it from a 2D format and start to play with some geometries in 3D. And I'm not used to doing tutorials like this, but I'm just going to run through a tutorial from start to finish, more like building a puzzle. It's not what I'm used to doing, but it's for those that want to see the power of this and go into scripting it from the beginnings. I will be using the C# node and some custom scripts coming out of Radii's C# node instructional courses, which I've tucked into user objects. So you won't be able to open this file if you got a hold of it on my GitHub, but you could if you got a hold of the user objects. I'll probably make this series available through Patreon to begin with, and free in a couple of weeks or a month once I get 10 or 12 episodes done. So this is pretty simple. I'm just going to start with some number sliders, and the way I'd like to build number sliders, and I don't usually do this, I build my script and then I bring this back. But since I have I actually have the script up in front of me, it's going to produce some interesting geometries. And I think everybody can follow along what's kind of happening in Grasshopper if you have basic knowledge. So I'm producing a number slider here, and I basically want a number slider that will run between 0 and 200. So I type in 0, period, 200. And that's a nice way to get a little slider that you start playing with. And I'm going to play with the numbers around, 2/3 of the way or 3/4 of the way up in that slider. And I'm actually going to call that my separation distance. And you'll figure out why after. And you don't have to do this, but it's kind of nice to do. And I'm going to use Python format for things like functions, not classes. So separation, distance. So that's, what I might end up doing with that number slider. Hit enter, and there it is. First number slider. I'm going to use another number slider that's going to go to 12. So I'm going to go from, I'll probably do 1 ... to 12, which will come out integers, and I'll set that pretty high to 12. And I'm just going to refer to that as what I call node count. Of course, these are just my choices for variables, and they're all integer or float variables, so they're not too hard to figure out. Node count, and then I'm going to do another number slider that's going to run from 0 to 10. So I just type 1 and hit enter, and I should be able to, actually no, I want to hit an integer higher than 1, but lower than 10, and I'll get a 2 to 10 slider. And that should be fine for a vector amplitude. And if I want to go in and edit that and pull it into a rational number so it's got a little more, this is just to visualize the vectors if I actually make it within the node. So I'm going to call that one an amplitude, an amplification of a vector. So I would just call that vector amplitude. And this is the way I don't usually build this way. I come back afterwards and build all these and name them afterwards after I do something creative. But it's kind of spontaneous what I'm doing. This might be a half-an-hour tutorial, so I guess you'll see that down to the bottom. I'm going to make another number slider and have this one run from 100 as an integer. And I'm just going to type in a digit higher than 10 and lower than 100, and it should come up. And what I'm going to do is I'm going to call this box dimensions, because I'll need a box to do what I'm going to do, dimensions. And once that's done, as enter, I'm going to copy that twice, copy and paste twice, and I'm going to use that for X, Y, Z. You can always straighten these up and use any format you want to level them out in between. And then I'm going to have another number slider that's the same. Actually, it's going to be the same size, but I don't want the same name. So I'll right-click and I'll put in population count. And that's because I'm using a three-dimensional kind of box grid generator. I can't remember the name of it, but we'll get into it. You'll see it come up. One tool I have here on this file is the one plugin I like to use, which is bifocals. And as long as you slide that in, you'll start seeing from nodes. So you pull down I'll have to go in and grab something a little more complex, like this node. If you're using the bifocal node, which is really nice, you can download that. It's one of the most common plugins. Everybody kind of says it. You're going to see that you can keep things on icons, and you'll see this labeled of polygon center. So it'll tell you what everything is. It doesn't name number sliders, and I don't think it names panels, but that's fine. Population count's going to go from 0 to 100, and then I'm going to have a divider, pretty small. I'm going to minimally divide by 2 up to 10, and that's going to be my denominator, which I'm going to use on an expression. Denominator, denominator. sounds better. And my last one I'm going to use, because I use it quite often, is a number slider. Pull it in here. I'm going to put that, well, I'll just seed 12, which will go from 0 to 12. Doesn't matter what it is. This is actually just a seed function I'm going to use. You can have multiple seeds, but it's nice to go back to an object that you like, so that's a seed count. So those are all my parameters, and I'm going to put them in here, and I'm going to group them. And those are going to be things you can slide around with and play with off the bat. Now, what would I build from this? Let's go in and put together something that's going to be necessary. We'll go into surfaces. We'll go into center box. And it's going to center that box right here on the center, which is nice. So we're going to use our box dimensions X, Y, let's do X, Y, Z. And now we have a box that we can play with, and you can always do zoom extends all. If I pull this over a little bit and just do that, and you get a nice box that you can kind of center and play with. That's one of the geometries I'm using. I put it in a box corner. I don't want that. I'm going to use an expression node, which I use quite often. I think it's the best one to use. If you're going to do anything, you just have to make sure you go in and change this variable to X, or otherwise it won't read unless you call it variable X and Y. And I'm going to just do a simple script in here. Couldn't be easier, X divided by Y, because I want you to be thinking of using math computers in this. And then from that, I'm going to take one of my box dimensions, because there's a 100 counter on that, and I'm going to do it by the denominator. I'm going to have these outputs that come, and I have a smaller number. So what that allows me to do is start to generate a couple of fun things. And what I'm going to do is, let's jump in here, make the screen a little larger that I'm drawing my examples from. I'm going to produce 3 nodes now. One is in mesh, which is a mesh sphere, and it's got a UV count. And that's one number slider I left. Let me tuck this one up here, and let me do a number slider. Let me see what I ended up choosing for a number slider. Oh, I just chose 100 number sliders, so we'll cut and paste, and we'll just call this one, I thought I was missing one, UV count, and we're going to end up using that one, and it's going to come in handy here on this mesh. The other tool we're going to do is we're going to jump in here because populate 3D, and we're also going to go into surfaces and grab a sphere. And now you can grab some data out of here. Obviously, my UV count is going to go into U and V. The radii, which I chose to use. Let me see what I chose. Radius is going to be this divider, so I get a smaller circle on the radius, a smaller circle on here. So I actually have a sphere and I have a mesh sphere. If you put this on, you'll actually see the difference, and they look kind of the same, but you see they're built differently. The reason I do this is because my C scripts coming out of Radii use meshes, not spheres, but I thought since they're close enough, there might be a little problem or optimization points if they get too close to a mesh sphere that's not a curved sphere, but I'm not too worried about it. And then my populate 3D is going to pull that region of that box. It's going to take a box count of the population count of 100, and I'm going to take that C to 12 and pop it in there. And you can add points to it if you wanted to, but I'm not going to. So those are our 3 things so far. Now here's where it gets interesting. And this is you've done the math, you've thought about the numbers. We're going to go a little bit into the computer side of this, which can be fun. I'm going to keep it here so I can keep zoom extends all whenever I get into something tricky. And I'll probably take geometries off as we go, so we're left with just these geometries, and you can see what's actually happening. A couple of interesting forms. The one thing I'm going to do now is test points inside mesh. And what I do is I have this node that whenever I want to know inside, test points inside, it's going to ask me for a mesh. And that's why I use this mesh. And the point-wise are going to be the population of these points. And I've got a tolerance on there. And now it's going to tell me, are these points inside or out? And these are all the points. And I did this little dispatch, points inside the sphere. And this isn't really necessary. But I'm going to show you what I end up doing. I'm going to grab a dispatch, which is a nice little tool in sets. So hopefully people find this interesting. I love the dispatch. It's one of my sorters that I use the most. The problem with the dispatch is sometimes you have to flatten the lists and data, but let's grab all of those points and let's dispatch out the ones that are inside, and let's take the points that are coming out from the outside only. So you'll see how all the points are there, and if you want to see the points, a nice little script here, which I'll show you the details of it, you can see that you have the points inside, you have the points outside. So it's a nice little tool for that. We're not going to end up using this one, but we're going to use this point, because those are points we may end up using as geometry. I usually throw a little something around them. Now you're going to say, okay, well, what's going on in there? So let's double click it and open it up. And it's a really nice C script. And Radii provides in her examples all of these extra using libraries. You don't need those for these scripts, but I leave them in because I end up using them on more complex scripts. And you couldn't see a more simple example. Well, you probably could, generate points, but here it is. It's pretty much a one-line script. Inside is what we're setting the output variable to. Is going to equal mesh dot is points inside needs a point, a tolerance, and a boolean to say true or false. That's the script in C. So if you have not thought of scripting in C or Python, begin with this, and your power will go through the roof. I think of C# nodes and GH-Python nodes as Lego pieces or erector set pieces. So I'm crazy. I mean, I literally go in here and I make my own scripts. If I jump in here and you see what I end up doing, let me haul this over here a little bit. You'll see I just generate all the time custom scripts that do things, loops, data, and I don't give my concept of anything. I just know that they generate wonderful things. And this playground for me has allowed me to explode into Grasshopper, enter a level of machine learning, robotics, data science, and we'll see where it ends up going. Not a lot of people do work like that, but it's the way I think, and so it's what I'm going to stay with. There is a little noise in the background, and that's just my kids that make life exciting. I'm going to take off these points now. I might leave them for a little bit, but I've got my dispatch. I've got my items. I don't need to see what's coming out of here. And we actually have these points that have been, you'll see those middle points disappear. And of course, that depends on the radius of the circle as well, dependent to the points being generated in the cube. So let's just go that far. Now, one thing I want to do here before I leave is I want to jump back into my surfaces. And I want to grab one of these centroids because I want to be able to grab the point of the centroid of what's going on there all the time. I'm going to match that with this point. Not much other data we have to bring in, but a nice little example now is to produce a line. And we'll pop this back up here. We'll go into curves, we'll grab a line, and we'll say, let's grab all of those points and grab all of those centroids and produce these lines from what's on the outside of that and how those lines end up going into the center of that circle. And you'll see that now I have a lot of control over geometry, so we're going to go a little farther. In fact, I'm going to go even farther to build some geometry. I'm going to go to an intersection physical surface curve and say, let's take these curves and take that surface going back to the sphere, not to the mesh, because you're not going to want to mesh in this situation, which is why I usually use quad spheres, meshes. You're going to see that I generate all these wonderful points from those lines as they cross through that sphere. So what a nice list of data. And whenever I produce things like that, I usually pop them out and say, okay, let's label them. So let's take the normals and know there's a vector there. Whenever I make a vector, I usually don't like getting lost in other things, and I'll grab a display. Actually, I think, yeah, it's under display, and I'll just have to bring this down a little bit, and I'm going to move my face over, and I'm going to do a display vector. And whenever I do that, I usually like to go to vectors and grab an amplitude. So then I can take my vector, I can pop it into the vector. Now, you can grab the vectors as the start point, but I thought since we're working from the points, let's put it in there. And then let's grab the amplitude parameter that we had at the beginning. So that's why I did a little amplitude. What did I do? Denominator, box dimensions, seed, vector amplitude. So let's pull that back over there. And some people don't like to slide around here and do all this stuff, but let's pull it in there and put it in there. And now we have a visualization of that vector. And we can actually see what's happening. More data, more fun, exciting. Now you'll see a bunch of points that pop about. So let's grab plane normals. So let's go into here, planes, plane normals, and let's generate at those origin points. Just making sure I do this right, and I throw the normal on those. That's going to generate these awesome planes, which are a little too big and crazy to look at. So what I'll do is go into display and say, okay, why are my plane sizes at 222? And let's take that down to 8, enter. And there you go. There's your planes on the surface, all set to surface normal. And you can orient them as other ways from the X and Y relative to those planes. The other thing I'm going to do is produce a point. And sometimes with points, when data starts to get a little funky, I like to simplify. You don't have to do this, but it's just a little thing that I'm kind of watchful of. And then because these are lines, but they're also curves, it's always good to remember that I might need at times curves and treat those lines as curves. But I also might need to, because I don't want to limit them, or want to understand exactly what they are, I might want to look at those lines. So what we have here is, if we take this whole thing, go to here, you can see what we actually end up visualizing and throw that one into the group. Now that's a lot of data to work with. you don't have to look at all your other stuff before that. You start taking off all this other stuff, and now you're left with this. And as you preview on and off, you can kind of select your items, and you can specifically select with color. And one thing to do is right-click here, go to Preferences, and pick the colors that you like looking at. I'm definitely one to like blue, so let's just throw that back into a blue color. And I don't mind the red, but I like a little more orange. It's just how my eyes work complementary, and that's how I see things. And you can change up the grid and do things in the Rhino window. But I try and do nothing with my scripts in Rhino. I never want a 3DM file that I have to find. If I bring in anything, I'll internalize it into a node. If you don't know what I'm talking about, I'll bring that up. Let's continue and see what we can do. Now, this is a fun little do-si-do. I want a list item out of these points. I actually want these points to give me a list item. So I'll go into list and say, okay, what items do I want? Instead of taking all those list items, I'm not sure why I did that. It wasn't in a list, but I'm used to grabbing it right there. Instead of grabbing all those list items and flattening those as a list to deal with them, so it puts them all, it's kind of like chopping down a tree and putting all the apples into one basket. That's what I think of. I am going to want to grab in sequence a random number. Now, random numbers will have decimals, so it's always nice to flow those through an integer value. So I'll do that, and I'll throw out and grab an index here. And then all I want to do is grab a list length of here, which is so good to have. And you can write this script into a C node or into a GHPython node. But with Editor, you get a grafted list or a list of lengths. You're going to want to flatten that as well because it's going to be a single digit. Throw that in here. And then what I want is a number range. And my number range, if I chase it back in my seed, obviously my number range is going to come back to my parameter. Of the node count of how many I want. So I'm going to grab my node count, shrink this down, and enlarge here. I'm going to want my number range to be here, which happens to be 12 values right now. And my seed, I just want to bring it back to here and pop it into my seed. And if you're bringing an arrow or a connector from a node back to one, it doesn't pop the other one out. I think that's really nice thing with Grasshopper. So we've got all these randoms. Take them off, and now we have 12 points instead. And actually, we could bring this count down to 3 if you want, just to show how this script is building geometries. Now, we have an awful lot of data. What I do is I either go into edit mode, click on here, and move it down to 3, what I want, or I will lock off the solver by hitting my center scroll wheel and lock it off while I'm doing activities, and then turn it back on after. That helps the script run a little better. So now what we have is we have these list items. I can take off all these visuals still off, and now I have these 3 points that do-si-do around all over this surface, and I can do something with them. So what will I do with those things? Let me look back at my other script and see what I ended up doing. I created a 2-point vector going back to the centroid from these points. So I'm going to go into vectors and vector 2 point. I'm going to grab the first item, and my other item is going to be my centroids on my spheres. Use that data again right here. And now I've ended up producing a vector that I can't see. So I've got to go back in, and I'll do this as practice the first time. Usually I just cut and paste it from what I have. Grab a vector display. The vector comes in here. You can use the vector. It's treated like a point to slide in here. And you have the vector display of what's happening. And then the other thing is you can put on your amplitude, which I did before, pulling the vector in, pulling it out. And since I had an amplitude parameter, let's slide that one back into... where's my amplitude? Vector amplitude there. And actually, it's a little smaller as 100. It was coming up bigger before. So there you go. Got a little vector amplitude. You get a visualization. You can take a look at that. Now, what I'll do is I'll put spheres on these points. Not too hard. And I'll put them according to those vectors. So I'm going to go back into my surface. And this is kind of the way I think when I'm building kind of creative geometries. Let's put those on the base. The radii can actually be treated as those vectors. You get these spheres, which have an amplitude. You can change the scale and size of those through the vector. And what I'll end up doing with those is a little bit of, it's a little clumsy. It's not the most efficient, but I don't mind using it. I do love exploding my tree. And you can explode this tree into something so much more. But because there's 12 pieces of data, if I flatten this, or if I graph this, you're going to see all the data. It's going to say, oh, you're going to need more data. Right now, there's 3 coming in as a count, but I can go up to 12, but it doesn't even register when I go up to 12. So I just look at it as, okay, I've got 3 wonderful things to play with. And at that point, all I want to do is a simple jump into unions, and I just want to show you a solid difference. And what I end up doing here, because I do run into problems a little bit with Grasshopper, just like in Rhino when you're doing these things, solid difference, solid union, and solid intersection. Now what I'll do is probably put this one first because that's nice and easy. I could just take all of the items and throw it into my solid. I'm pretty sure I could just throw that all in as a sphere, those reps, into the solid union, and I end up getting it, and it's done. But to produce the other two, they're a little trickier, and that's why I did my little exploded tree. I'll take this one and put it into this rep, right? And then I'll do that again. I'll take this one and put it into the intersection. And sometimes you have to do this, and it's one thing that slows people down. Like I said, it's a clumsy script to do it this way. But then you take that rep and you put it into that last one, and you kind of have to walk through this. And I'm a little embarrassed to do this, but I do know that it makes a lot of sense to people when they start. So now you have your geometries here that if we just did a little bit of movement, very simple, the simplest transformations in my opinion, unless you're spinning a circle or spinning a sphere from its center, is do a little quick move. And we're going to move an object here. We're going to move it in two directions, the one of which is going to go negative, and it's going to go red because it doesn't like negative. It likes direct. It needs a vector, or it's going to go orange. And we're going to go in an X direction, and we'll use that X direction to go to the negative direction, and positive direction, we'll take this geometry this way, we'll take this geometry this way. And then I think I ran back my X factor to my first parameter. So it's strange enough that I built my first parameter to end up plugging in last. Now, looking at my data, the only thing to really do now, which can be a little interesting for people, is pop over to your perspective window and go to render. And with that, I probably did a little data visualization using display, custom preview. We'll do 3 different colors, and you can choose that. Take your geometries and put them into each one. You've got nice closed watertight reps, and then you want to go into your parameters and your inputs. Grab yourself a gradient if you want, but something simpler is just one of these color swatches. You can pick your colors that make you happy. White's not going to come up too much. And there we go. And it's got a default color, but you can go in here, just give it a little right click, and we'll do a little blue, which I like. We'll do a little purple, and we'll do a little, where should we throw that one? We'll throw a little orange. And that's it. It's not the best colors in the world. If we put those on and only saw those colors, we could end up going back to our script, a nice little script to practice with, turn it off, and you've got the ability, going in here and zoom extends all, to preview some pretty cool geometries and have pretty fast parametric control. You got to think what I'm missing here. I think in my display, what was this one under? Preferences. Is it preferences? Right click, preferences, solver, widgets. We probably want, what one am I missing? Why am I forgetting my, it's been so long since I looked here. Widgets, solver, profile, palette. It's been so long here since I've taken it on, but it'll tell me if the script's running slow or not. But that's it, and I'll throw these last ones into a group, and I'll probably center them up and make them look fancy. And you can have them disappear or come on, but in render mode, they're going to come up because of those preview colors, unless you turn them to preview off. Actually, I think you can leave them preview off. And now you have this really nice ability to go in and say, okay, what's the separating distance going to do? That's going to move pretty fast. The node count's going to make that middle one jump up. It's not going to affect the sides too much as the intersections, but it is pretty, and it's not going to affect the intersections because I'm not running. If I set this one up to 5, this is where the script gets a little playful. You're going to have to go back in here and do a little more, and it's not the best script because then you're going to have to use these additional numbers to do additional unions. So we're really only looking at our first object. We're going to use this one, so you can take these ones and do disable, and really it's only really functioning with that middle unit. I just like to do those other things on the side to show the sidecars. You can see how this one kind of bubbles up and does all these crazy unions. And then with that, you've got the effects of the vector amplitude, which are only for vector visualizations. But now you've got UV count, which is really dealing with the detail of that what the spheres look like. You're not going to see that until you take it to bake and start looking at wire lines or things like that. Your UV count will have that kind of finesse or whatever it's called. And then you've got this wonderful ability of box dimensions to start to really play with things in the X, Y, Z. If you play off of those, you end up with these kind of jeweled single objects. And what's nice is unless they're totally separate and not touching, these objects are one closed single rep. Which is really nice because it's done all that union for you in Grasshopper. You don't have to do anything in Rhino. So a nice little parametric model built from the beginning and end. I don't usually do those things. I'll put this on my GitHub. I'll have the files there, and if you want to have something run, you could always, I'll just leave this up at the end, you could always try a script, putting in your own libraries, which are here. I'll just leave those up for a second. You can hit pause on that and check out what you have to type in for using. And literally, the script itself is this one right here. 3, 2, 1, you take that in, and you'll hit play, and next thing you know, you'll have your C going, and you're starting to program in C. And slowly, you will tuck all of these visual nodes that are very basic in Grasshopper into that C node if you wanted to make this a particular geometric user object or plugin. But I'm not really into that. Like I said, I really like just producing a ton of custom GHPython nodes with the WS, which are all available on my GitHub and through my Patreon for some, but most of those files are open. I've done Python one-liners for machine learning. I'm self-taught, picked this up 3 years ago and just went nuts with it. So hopefully I can end up collaborating in this fun exercise of playing around and building different geometries and knowing how it scripts and following it logically from beginning to end is an exercise that really lets you start digging deeper beyond the syntax or beyond node scripting to the problems you actually want to solve and geometric exercises you want to do. And then if it becomes dependent on data and you're running into data sources for machine learning and using those algorithms, that gets pretty wild. Of course, our seed is just this little do-si-do of what do we want to produce. Put these in the videos, put them into the MP4s, into GIFs, and show everybody how smart you are and how much computational design has changed your life. So thanks very much for watching. Michael Wickerson, Wickerson Studios.